The carbon cycle describes how carbon transfers between reservoirs located on Earth. This cycle is important for maintaining a stable climate and a carbon balance on Earth. Carbon is an essential element for all life forms on Earth. Whether these life forms take in carbon to help manufacture food or release carbon as a part of respiration, the intake and output of carbon is a component of all plant and animal life. Carbon is at a constant state of movement from place to place. It is stored in what are known as reservoirs, and it moves between these reservoirs through a variety of processes, including photosynthesis, burning fossil fuels, and simply releasing breath from lungs. The movement of carbon from reservoirs to reservoir is known as the carbon cycle. In our conversation in this episode, we have the opportunity to talk to Flora Moon to learn more about the circular economy and the role of regeneration officers. Well, hi, Miss Moon. Thank you so much for joining us on this episode of the Energy Transition podcast. We're so happy to have you here.
Thanks for inviting me.
Can you tell us a little bit about your career, such as your current role at Holon Computing, and how you became involved in sustainability and nature-based solutions and regeneration for climate change?
Yeah, so I'm one of those odd employees of the energy industry. I'm not an engineer. I started out in filmmaking and had a career in high tech and ended up at Chevron as a change management consultant. And in that time, I realized that I maybe could influence and help people understand that sustainability could be part of their job. And as a result, was introduced to many people who are part of a large professional organization called the Society of Petroleum Engineers, which is where I met Jim Crumpton. So I am the Chief Regeneration Officer of Holon Computing. And there's a lot to unpack there because regeneration is actually an ambition beyond sustainability. Sustainability is the idea that you do less harm when you do business. Regeneration is really about how do you partner with the earth, with nature, in order to help nature do its work. And there's a lot of reason to think about the future in that way. And the main reason is because, actually, let me start again. So I'm the Chief Regeneration Officer of Holon Computing. And I want to make a distinction between sustainability and regeneration. Sustainability is an idea that came out of the late 90s, and it was the concept of doing less harm when you do business. And I've been advocating in the oil and gas industry the idea of regeneration, which is partnering with nature to help nature do those processes that have allowed humans and all other life to thrive on the planet. So how I actually got there is very circuitous. Early in my career, I was a filmmaker for public television in the United States, and then ended up in high tech and realized that I really needed to do something that was more meaningful and had been a steward of the planet, recycling early on, and decided, well, maybe I could do something to do with sustainability. And it wasn't until I actually began to understand that sustainability is really around Earth systems and thinking about systematic approaches to some of the big problems that we're facing right now that I ran into several kinds of research, one from the Stockholm Resilience Center and Johan Rockström, who talks about planetary boundaries and how the Earth, if you think about the Earth as a system, it can only accommodate so much activity, including pollution, weather systems, all of those things that have been regulated all along, as long as we stay within certain parameters, physical parameters. And we've actually exceeded 6 out of 9 planetary boundaries, which is causing much havoc. Some of it is climate change, which we all are aware of. The loss of biodiversity, like 50% in our oceans since 1950, up to 70% in some of our terrestrial systems. So on a planet that's out of balance. And then the other piece that fell into place was some research called in a field called ecological economics, and an economist named Kate Raworth, who actually combined this idea of planetary boundaries with an economic lens, because we humans tend to frame everything in economics. So it was a way to convey some of our situation in uh, a more compact um, language. And economics is actually something that a lot of people understand.
Absolutely. And could you explain a little bit more what can you tell us what a chief regeneration officer does, especially in like your current role at Holon Computing?
Sure. So Holon computing is best described as a nature-based computing technology, but it's not in the common sense word of how we use computing right now. It's really thinking about if you had been able to design a computer that allowed you to make better decisions rather than the model, which was make big calculations, which is what we're doing now. What would that look like? And so I work with two engineers who have thought about category mathematics as a language to compare concepts without losing or having to digitize those concepts. So you retain the context of a solution. And if you actually compose them, you can actually identify the salient uh, information and context that's going to allow you to make good decisions. So if you think about the way we make decisions in business, and it came out of working for a highly complex adaptive system in the energy business, integrated oil company, um, a lot of decisions are made because there's a time factor, there's a schedule factor, there's a budget factor, or the boss needs a decision to be made. And this does not really facilitate, uh, I would say, comprehensive decision making. It facilitates um, a quicker decision criteria by removing certain uncomfortable or inconvenient or complex uh, data sets and information sets. And let me talk about that again. Sorry. So this is all very conceptual. So Holon computing is really about how do you compose concepts of complex decisions that need to be made without digitizing or throwing away information. And the way we're thinking about doing that is using category math and maybe natural substrates. We don't actually know yet because we don't think that the technology will really exist for another 10 years. But it's like moving from a slide rule. Well, you may not know what a slide ruler is, but when you did calculations, it was literally a ruler with a reticle and moving parts. So you could calculate logs and other mathematical um, calculations. So moving from something that looks like a ruler with movable parts to a personal computer over which you and I are communicating is totally foreign idea. When you were in the 50s, thinking about this, how could you even conceive? So this is sort of the roadblock that we're figuring out how to address when we're talking about a new basis for computing, and the computing is not calculating, but it's actually composing. So as the chief regeneration officer, my task is to figure out how do you actually embed regeneration, which is care for the planet and partnering with the planet, in how you build the business and then how you run the business, including whoever uses our products, how we manufacture it, how we distribute it. It's sort of the whole value chain. So it's actually a very broad and wonderful challenge.
Yeah, absolutely. And when you said the process, of identifying the context in order to, make the good decisions with these models. Is it focus is are those models focused on specifically the sustainability application?
So maybe it's called regenerative knowledge management is the way to think about it. Is that we're what we're trying to do is preserve context. And that's an incredibly complex problem. And the way we do it currently is to process large data sets. And then as humans or experts, we apply the context after you've looked at the data. So we've stripped context away, reduced it to ones and zeros, and then put it back together and then apply context with uh, expertise. A regenerative way of looking at this is what if you could think about concepts as objects, and then you look at the effect or impact of decisions using these sets of objects, and you still have the context. You're not interpreting anything. You're laying out the parameters of what might be the uh, ingredients of a good decision. I don't know if that makes sense to you, but it's really taking away the granular processing of information into digits, into really organizing concepts so that you could look at them within a context of a decision-making environment.
Okay, okay. So yeah, so in the terms of, context um with the application of these regenerative models, it's could you maybe explain more about what preserving a context is?
Yeah. Well, so there was an experiment that we did in engineering, which is in every large company, there's a big engineering manual, right? It's probably 6 or 12 linear feet if you had to print it out, or maybe more. And it's really difficult to maintain either a current version and make sure that everyone has a version. And so we did this experiment in which two engineers were given the same set of specs and were told to design something. And normally, what is done is that a team is built and somebody guides the team to make a quote good decision. So instead, we said these two engineers, they're both senior, they're qualified, totally qualified, were given the specs and they went off and they created the design spec and they looked radically different. Okay, so no overlaps in equipment choices or problem solving or any of that, but they were equally valid given the categories of specifications that they chose. When they were compared, they were both equally uh, equally good, is the way to describe that. So it was, instead of saying what was the granular decision of which widget did they specify and how did they solve certain problems, they looked at it in terms of categories of decisions that were made and was the decision-making process good.
Just to show you how old I am, I wanted to show you I have a slide rule right
Oh my God.
going back, and this was my first calculator with
Yeah.
regard to that when I started the university. So um, I'm almost back to the Greeks, in terms of that kind of way. But I mean, you brought up some really interesting challenges, and I think we talked to an expert in transportation last first season, and then she was talking about instead of just trying to make incremental progress on challenges, engineering challenges, environmental impact of extractive industries and things like that. And we are doing that already, right? We're making little better decisions, along the way, and we're reducing emissions or footprint a little bit along the way. But you add them all up and it's not the goal. We're not getting to the goal, the rest of that. So she challenged us to that what we really needed to do instead of these incremental decisions, which I think you described very well with regard to how we calculate, right? We're trying to calculate a whole bunch of numbers faster, but we're not necessarily in that model trying to create better decisions. It's just faster calculations. And Moore's law has certainly given us the background to do faster and faster decisions. We're already talking about that. Um, but reimagining the problem, and I think, going back to what you're talking about, you've introduced a lot of new terminology, that I think, an engineer doesn't normally get in their training. You talked about planetary boundaries, you talked about regeneration, sustainability. Um, uh, I'm sure that there's the cyclical economy, and there's a whole vocabulary that's kind of different, and that needs a one of your colleagues I know has this idea of the sustainability mindset, and so that really challenges us to sit back and think about a problem completely differently. Or, as you said, two people, same specs, same operating best practices, engineering manuals. I had one of those. Not there isn't. It isn't a book. It's a whole library, right? With regard to those, yet come up with different solutions to a problem. There's one other term that I think I'd like you to just kind of dive into, that I think is also pretty important when we're thinking about not only the planet but the people on the planet, and that's the idea of just transition. Could you describe in your perspective what that means?
Yeah, I think we have to set a context for transition. And the energy transition doesn't affect everyone equally. And depending on your economic and social circumstances, you either have more or less to lose because of the transition. And what do I mean by that? Um, Energy transition isn't just about changing technology. Energy fuels our human activities. So if you actually change the fuel source, so whether it's oil or coal or wood or electrons captured by the sun, those have economic implications that not everybody can accommodate. So if you think about the indigenous peoples, let's say in less developed countries that rely on wood, the energy economy actually means little until they're forced to maybe put in electricity in their houses if they're able to. And then what is the economic decision that they're able to make if they only can put in solar and there is no grid? I mean, so there's a lot of sort of sociological and ecological and economic conditions that are attached to the energy transition. So for the just transition, it's everyone needs to be able to live well and equitably, no matter what the energy is that they are using. So there is a great deal of worry about how much pressure there will be for these developing countries to deploy technology at the economic and sociological well-being expense of their people. So energy transition is really about just access to energy, no matter what economic class that you're in.
I guess we're already starting out at our start point is with energy inequality and wealth inequality in the world. So we already have some people who have greatly benefited from the industrial revolution and the fossil fuel source, and an energy transition that looks right to them is not going to look even recognizable, right, to some of these other cultures, other sort of populations. And I mean, we talk about, we don't even have to go back to, we don't the sub-Saharan Africa or Southeast Asia. In Native Americans on reservations in the United States, I read where 1 in 10 households on the Navajo reservation in New Mexico and Arizona don't have electricity or running water. So, I mean, some of this stuff's in our backyard. And in season one, we talked about just heating and cooling in a hotter planet, and maybe people in a poor section of Los Angeles, don't have the same kind of perspective on some of the changes, some of the ones in the richer, kind of neighborhoods that are just miles away. So I think that concept of just, I mean, we have a tendency, I guess, in our society for the rich to kind of impose an answer on the poor. And maybe this is one where we need another to step back and say maybe a just transition in a developed world isn't the same as a just transition in a developing world.
So I would say that any kind of change cannot be a blanket change, even though that's more efficient and people think that might be more effective. I mean, because it's really not thinking about the conditions on the ground. It's thinking about from some 50,000 foot or 100,000 foot level, oh, we'll just make all those blue areas green. It's just saying, in the same way, I can't impose regenerative practice on the globe, even though I'd love to, because people don't have necessarily the wherewithal, but I can recommend that partnering might provide these kinds of benefits and make a case for at least thinking about it. But I think trying to impose technology on anybody or any kind of massive change like that is fraught. And justice is often the last thing that's considered because the other things like efficiency or economics tend to trump everything else.
You're right. We tend to run on concepts of efficiency and of speed and and things like that rather than justice and other sort of maybe less quantifiable factors, but maybe more important ones.
Agreed.
Yeah, and last season, one of our speakers said that, the good news about the energy transition is that we have the chance to rethink most of our energy solutions and systems. But on the other hand, the bad news is that we have to rethink most of our energy solutions, and the scale and complexity that comes along with it, and the challenges. It can be overwhelming, like talking about that blanket change, it's not able to cover the reality of like, the energy demand. And one way that we can rethink energy systems is through the lens of behavior change and a circular economy. Could you tell us more about what that looks like?
Sure. So the circular economy is really thinking about economics in the way nature would do it. So in nature, nothing goes to waste. Every waste product becomes a feedstock for another process. So for instance, uh, think about an ecosystem like a forest where there are insects. Insects eat decomposing materials. Birds eat the insects. Birds live in the trees. The trees get the nutrition from the water and the decomposing materials. And these processes produce carbon dioxide and oxygen and allows everything to thrive. So this is a circle. It's a cycle. When we created our economic system, we created a linear system. You take something, you make something from it, and then you toss it, you throw it away. That's a very linear system. And in fact, it's taken quite a while to divest ourselves from the idea that there isn't a way we can throw something away. So a circular economy is really saying if we don't have a concept of waste, what do we have to do? And it's actually much like what we're talking about now, is rethinking the whole value chain and then the whole supply chain and sort of everything that is involved in business. There's a really good example. I've been involved with the U.S. Business Council for Sustainable Development a couple decades back, and they're part of the World Council for Business Sustainable World Council for Sustainable Business Development. And they've been both organizations, the global and the US, have been very active in rethinking how businesses actually could operate in a more planet-friendly way. And this is not because they're tree huggers, it actually makes economic sense. because there is a cost associated with waste in every single industry. So the US Business Council came up with they call it the industrial materials marketplace. And it started with industries in a region saying, hey, I'm a pharmaceutical company, but I have high grade solvent waste that could actually be useful in a chemical company where the parameters are not the specs don't need to be as stringent. Why can't I start selling my solvent from my pharmaceuticals, which are really, really high grade, to a chemical industry? Well, there turned out to be all kinds of regulations that were quite a bit safety related. And it took about a decade to regionally make agreements between like the Great Lakes region or the Gulf Coast region, where companies could make these bilateral or trilateral agreements to exchange waste products as feedstocks. So now this is a very viable marketplace where you can take things like used stainless steel or used wood pallets or any kind of quote waste product once your process has been completed, even if it's just shipping material and you've got all this shipping material that you've got to get rid of or packaging material. So that's an example of circular economy. One example is using the waste as the process has been created. There is a new version of that with plastics. So plastics are now being redesigned instead of being polymers, which you cannot recycle, into monomers because actually it's less economic, it's more economically viable to create monomers because then it can immediately be recycled or it can be decomposed and then made into new plastic. And it doesn't have the problems of trying to decompose polymers into monomers. I hope that makes sense. But
Yeah.
so redesigning a process from the get-go to design out waste is another way to approach a circular economy.
Yeah, I think you bring up a lot of great points. Thank you.
Yeah, so there is one thing though for the energy industry. I've been involved in the energy industry for, 2 decades, and the energy industry are tribes unto themselves, I would say. And it's going to take a bit of behavior change because the new way of designing and the re-resourcing of waste is going to force the industries to start partnering with people that they don't normally do business with. And so that is sort of a cultural hurdle that the energy transition is going to be sort of encountering because I think that in the past years, the energy industry liked doing business with itself. And you had these huge, huge conglomerates that, had these different vertical and horizontal industries that were all integrated. So you could do that. But now, as things are being disrupted, it's going to be more difficult.
Kind of make new friends with regard to some of this stuff. But you know, we've almost had a mindset of planned obsolescence. As I want to develop a new cell phone that oh my God, I've got one that's 2 years old. I got to get rid of it and got to buy the new one, right? So we even have that on our marketing, advertising, whatever, and we're kind of ought to throw something away and then buy the new, and then we don't we don't think about what happens to it once we throw away. But even now we've had the ultimate place where we throw stuff away, a landfill. You can drill simple wells and recover methane from decaying organics and turn that into energy, right? So there, or you've got an idea of at least keeping that cycle going, worrying about a balance between input and output. If if their output is going to go to an input, as you said before, into something else, again, there's a new handshake that could be a very profitable business one with regard to all of that. Um, one of the industries that I haven't read a lot about, but a little bit about is it's like soft drinks and Pepsi. I mean that yeah, they have a little bit of flavoring in it, but it's mostly a water business, right? So all of us, and you can't just think about energy and some of these other inputs. You have to think about water. And I think there's this area that now maybe we've upset some of the planetary systems to the point where there are more droughts. There are also more floods in other places with regard to these things. So how does this concept of not just carbon but water cycles, begin to think into these new systems?
Well, I'm glad you bring that up because regeneration is looking across all of the planetary processes. And so climate change or carbon is just one focus, and it's very myopic actually. Um, when you bring up water, I mean, water is, as we know, is essential to life, and sponge cities or the capturing of water in place, right, is something that always happened before we started paving over everything and knocking down trees and removing carbon from the soil. So sponge cities are an attempt to replace the water capturing capability at what we would think of as an infrastructure level in a city. And the way we do that is really thinking about a set of nested processes that move water and nutrients around the planet. And that's what we call at the sort of day level weather, and at the climate level sort of weather systems, right? So because we have this engine, and if you look at any of the things from NOAA or any International Weather Association, you actually see the distribution of water, and along with the water are nutrients, almost looking like as the planet is breathing because of the seasons. Then you also see weather patterns, which are basically driving the water around the planet. And that's impacted by ocean currents and the amount of water that's transpiring from the earth. So there's a whole set of research that's now coming to light that's talking about the evaporative and evapotranspiration, which is basically water transpiration, which creates this low set of clouds, which allows clouds and weather systems and weather patterns to form. And our hardening of the surfaces by paving and by cement and by deforestation has actually reduced the Earth's capability to actually evaporate water vapor into the air. And so we've seen these excessive droughts in the southern Mediterranean and along the coast of South America, sorry. And then the desert bands are increasing because we've tampered with the Earth's capability of being able to move water around. And that's partly because of the heating. And the other side of that is actually what you talked about, which is the drought. So we're now having patterns of drought and flood because the efficiency of the earth to create these weather patterns that distributed water in the way that we have all grown accustomed to has been disrupted. So really, sponge cities are a local attempt, no matter whether the sponge city is the size of Los Angeles or a small town in the US, is restoring water absorption. And you do that multiple ways. A lot of it is there's been a lot of academic research in terms of soil retention of water is dependent on the microbial and fungal capacity, the fungal and microbial density in soil. So the higher the liveliness of the soil is, the better the water is retained. So there have been pictures in social media. We have two glasses of water. I don't know if you've seen this, where you have a glass with a pile of soil has been dropped in and it retains its form for a week or more. Whereas the degraded soil, you pop it in and it totally disintegrates. So the soil structure is what allows the planet to retain the water and keep it in place. When there is no soil structure, the water runs off and helps with the flooding. So that's one of the things that I'm getting involved in as part of the regenerative practice of Holon, is that we're looking at rebuilding soil at a large scale level, and then calculating the composed impact of that. So creating a sponge city, but not necessarily airport-sized sponges, but maybe smaller scale, but more of it. I don't know if that makes sense to you, but that's what I'm involved in.
No, I think again that from small scale to big scale, we have a lot to reimagine and a lot to kind of think about because we've been on this linear path as you kind of mentioned, and that an old folk song from my early days, Joni Mitchell, they paved paradise and put up a parking lot, right?
That's right.
Maybe we've done too much paving. Maybe we've done too much of that. And actually, if you want to go back to when humans used to be able to understand this balance, um, the natives, the indigenous people, they did a better job of it than we did, than we
Sure.
are doing now with regard. So maybe we've just forgotten some of the lessons.
Yeah.
Yeah, and the you've been working in behavior and culture change for 2 decades now. What are some of the opportunities and areas of potential improvement that you see?
So I think the very first thing is we need to realign our relationship with nature. And what I mean by that is, especially like in oil and gas, nature is often the enemy, and we have to sort of guard against the worst effects of drought or floods or hurricanes, especially here in the Gulf Coast region. So if we realign our relationship with nature and think about our identity as a partner with nature, that allows us to tap into these planetary processes that worked for centuries and really reinforce or reestablish that capability by doing these earth-friendly practices that we just talked about, like restoring the soil. I think if we can do that, then we're actually going to mitigate the worst parts of our carelessness with our disregard for actually the natural processes. I think realignment takes time, but if we do this now, we and our businesses that we work in and the institutions that support our society actually have a chance at addressing some of the worst impacts of climate change and loss of biodiversity. And that's one of the reasons why I think the UN Sustainable Development Goals, as complex and flawed as they might be, they're the only global agreement that nations have signed up for to try and address some of the worst calamities that we're looking at now. I think that students could think about becoming ecosystem scientists. So as part of their remit, if it's personal, that's fine. I don't care. It's instead of only specializing in specific disciplines, is becoming place-based general scientists. So there's a wonderful book called Range, and it's about generalists. And because generalists provide a more system level view of things sometimes. And what we get a little bit blind when we only are very specialized in very narrow silos. And I would say I've noticed oil and gas is often guilty of this, is that unless they're just for a personal reason, they decide to have a general knowledge about gardening, for instance, where you have to be a generalist in order to succeed at gardening. We need more systems thinkers. So however you want to explore that, I would highly encourage that. I would say that the other thing to really consider is look into this thing called biomimicry. So it's the engineered view of how nature actually solves problems. And it is being deployed in lots of different industries because it allows people to have the confidence that there is some rigor in science and maybe some quantification, some processes that have been outlined that allow you to address a problem in the same way nature would. And I would say that caring for nature and caring for the planet is actually caring for ourselves.
Absolutely. And how could energy professionals take part of this regenerative practice in their jobs?
So I think there are a couple of things that if you just sit as you're making any decision and say, is this decision going to impact the nature, the energy consumption? So if I'm ordering something from Pakistan, for instance, could I order something closer so I don't have to have those energy miles and carbon miles, right, attached to whatever it is I need? So it's sort of sourcing is one. Does it have a social impact? Can I make a different decision that has a better social impact or outcome? And it could be the fence line social, it could be the region social, it could be the country social. So it's just asking yourself some of these priming questions like, okay, here's the one that people are looking at. Can I ask a few different ways of looking at it and make a better decision that doesn't impact the society and doesn't impact the environment in exactly the same way?
I think there's some humility that needs to be involved here, where man doesn't have all the answers. Maybe women do, but men certainly don't have all the answers. But it kind of at the end of my career, where I'm sitting here, I used to, we're oil and gas, extractive industries, mining, et cetera, have gotten, the rap that we're the destroyers of the planet and we're, rip everything up. And we have made a whole bunch of mistakes. But when I was a young geologist, doing mapping and in the mountains in Colorado or Western United States, I mean, I loved being out there in nature. I felt that I was an environmentalist, right? With the ideas that I was trying to do and the understanding of nature and certainly the rock part of it, maybe not so much the water part of it, but um, and I think we've lost that. We've lost that battle. We even lost the attempt that we may be really part of the answer, not the problem. Just looking at well, we need to look at the problem differently. We need to look at again, what would nature do, right? That would be kind of a very different way of looking at some of these kind of problems. So I think there is a chance, maybe not for my generation, we're already too far along, but in Mila's generation, to just reimagine some of these energy slash water slash organic slash economic slash engineering, 'cause it's all the generous thing that you talked about, right? There's a little bit of all of that stuff that needs to go into probably what is the optimum solution. But we're greatly honored to have you on the podcast. You presented some new thinking, and that always makes us grow. Are there, as we close here, are there anything that we're trying to reach a broad audience. We're trying to reach the next generation workforce. We're trying to get them to think differently, maybe, just with regard to some of the challenges that they will face in their life for their world. Is there anything else that you'd like to slip in here at the end of our interview, so where that you think we need to learn about too?
Yeah, so I think a lot of young people find it difficult to be optimistic because there's a lot of bad news out there. Um, and I actually just recently presented a paper about being optimistic and how you can actually make a choice to be optimistic by just looking for those glimmers of things that are going well. We're not a Pollyanna approach, but it's really saying if you actually look for it, there is progress being made. While I wish it would be faster, there is progress and there is an opportunity for everyone to make a contribution towards that progress. And so I would ask that if anything resonated today, that your audience says, I'm going to look into seeing if I can do something. And I'm not telling you what it's going to be, but working to regenerate, I think, our societies and our planet is a wonderful mission. And it doesn't have to displace anything else that you do. It can be an and. It's not an either or. So I would encourage everybody to choose optimism as a way to navigate in these difficult times and choose regeneration because partnering with the planet will only give you a much fuller life.
Well, thank you so much.
Flora considers herself one of the odd employees of the energy industry. She started out filmmaking and had a career in high tech, but ended up at Chevron as a change management consultant.
Now, as the Chief Regeneration Officer of Holon Computing, regeneration is an aspiration beyond sustainability. Regeneration is how you do your partner with your Earth to help her do her work.
Influenced by the Stockholm Resilience Center, which is a concept of planetary boundaries, but we have already exceeded about 6 of the 9 boundaries in the framework, which is climate change and loss of biodiversity. We're on a planet that is out of balance.
And ecological economy, most people think of it in terms of economy instead of nature-based systems. So this approach was attractive to Flora in thinking about sustainability.
The concept behind Holon computing is category map. How to preserve context is a very complex problem. Instead of calculating it, composing to achieve better decision making is better.
The energy transition doesn't impact everyone equally. We have different things either to gain or lose, depending on our circumstances.
Any kind of change is not a blanket, one size fit all approach. Although it may look more effective and efficient from one perspective, it won't just be from another viewpoint. You can't impose the technology on anyone.
The circular economy is thinking about economics in the way that nature would do it. In nature, nothing goes to waste. Every waste product becomes a feedstock for the next process. Our current human economic system is linear. You take an input, make something, then toss it away. We can establish processes that design out waste.
Considering the water cycle is important as well. One example is the concept of sponge cities.
We need to realign our relationship with nature and think about our responsibilities as a partner with nature, not as the enemy of our efforts. We need more system thinkers. Look into the concept of biomimicry.
A quote from this podcast episode is, "She chose optimism as a way to navigate in these difficult times. Partnering with a planet will always give you a much richer life."
You read about artificial intelligence or AI every day, but I was surprised that AI could be a factor in the energy transition, both as a sophisticated way to develop new solutions and optimize current processes, but also as a new source of growing energy demand with new data centers and computing chips that are very energy hungry.
No kidding. Data centers are not what they used to be before the AI revolution. Data centers have exploded in terms of power consumption. 10 years ago, a 30 megawatt center was considered large. Now a 200 megawatt facility is considered normal. I don't think the utilities sort of industry saw this coming.
I don't think so either. I think this was a surprise to most folks. In our episode today, we have USC professor Dr. Benham Jafarpour from the USC Information Science Institute to help us better understand the opportunities and challenges of AI and how these new hyperscaler data centers are impacting energy demand forecasts.
Some of the tech companies from the Silicon Valley are even turning to private power contracts, where they negotiate deals with geothermal and even nuclear power generators to run their new data centers. These new AI GPU chips are very energy hungry and have changed the way data centers have been operated. This should be a new real eye opener for us.
I finished my graduate studies in 2008. I was a PhD student in civil and environmental engineering, looking at subsurface problems and trying to characterize flow and transport in subsurface systems with applications across energy and environment. And at the same time, I was trying to get a master's degree. I signed up to get a degree in electrical engineering at the same time, trying to see how we can use signal processing and image processing tools in order to help us better characterize subsurface systems. So that's how I got into subsurface energy and environmental applications. I had a 4-year position at Texas A&M before joining USC in 2011. And since I've been here, I've pretty much continued the line of research that I started as a PhD student, with broadening it toward different applications in subsurface, including conventional energy systems, geothermal reservoirs, more recently looking at CO2 storage systems. And my lab at USC is called Subsurface Energy and Environmental Systems Lab. And what we're really trying to do is leveraging different disciplines, mainly the system science, data science, and AI, and insight and understanding of subsurface flow, and trying to combine these in order to come up with innovative ways to characterize subsurface systems, their properties, try to predict the behavior of these energy and environmental systems at a larger scale, and try to optimize the performance. So we develop workflows for these type of applications.
Thank you so much for joining us for the future of energy. Special thanks to each of our guests today and to our technical wizard, Abhi, for his important contributions to this episode. Don't forget to subscribe to our podcast so you can automatically get access to all our new episodes. You can find us on Apple, Spotify, YouTube, or wherever you get your podcasts.